Hello students, hope you all are doing well. So in our previous class we have discussed about the graphical representation of uniform motion. In today's class we are going to discuss about the graphical representation of non-uniform motion. Now let's do a quick recap. What is non-uniform motion? When an object travels unequal distance in equal interval of time, these kinds of motions are called non-uniform motion. Now let's see an example. When a body A, suppose we have here a body A, it travels from here to point B and then to point C and so on. Now in traveling from point A to B, it takes 1 hour and the distance traveled is 3 km. From point B to point C, the time interval is again 1 hour and the distance traveled in this case is 1 kilometer. And from point C to say point D, the time interval is 1 hour and the distance traveled is 2 kilometer. Okay, now let's plot this in a graph. So we have taken a distance time graph. Distance is in y-axis, it's in kilometer, unit is in kilometer, and time is in x-axis, the unit is in hour. Okay, so in the first 1 hour, so this is your 1 hour. 1 hour the distance is 3 kilometers. So I have plotted over here. In the next 1 hour means 1 plus 1, 2 hours. So in 2 hours the distance traveled is 3 plus 1, 4 kilometer. So I have marked here again. In the next 1 hour, that is in our third hour, so the total distance in third hour is 3 plus 1, 4 plus 2, 6 kilometer. So see, in the third hour I have marked as 6 kilometer. Now see, this is not a straight line as we have seen in case of uniform motion. So this line is a crooked line or a curved line. So we cannot join these lines with the help of a scale. So we need to do freehand drawing. See, here I have drawn a freehand line over here. So as you can see, the graph is increasing at some point, then again decreasing, then again increasing. So here the speed changes, that is, sometime it accelerates, sometime is deaccelerated. Deaccelerated means retarded, that means the speed decreases. Now let's find the speed when the body travels from point A to point B. Now point A to point B, the unit formula for speed is distance into time, distance by time. So in this case distance is 3 kilometer, time is 1 hour. That means 3 kilometer per hour. From point A to B. From point B to C, again if you calculate it like this, the speed will come 1 kilometer per hour. And in point C to D, the speed will come as 2 kilometer per hour. That means in the first hour, the body has traveled with most speed. That means the speed was highest. 3 kilometer. In the next 1 hour, what happened? The body slowed down. That means the speed, see here, the speed was increasing. Suddenly the speed dropped. And again, after from C to D, the speed has increased. So you can see that in non-uniform motion, speed is never constant. It keeps on changing. Now let's see the graphical representation, simpler graphical representation. So distance is in y-axis, time is in t-axis. This is an upward curve and increasing slope indicates that distance increases with time, that is speed increases. So when we say that speed is increasing, what we have to draw? We have to draw an upward slope. So here is another representation. Distance is in y-axis, time is in t-axis, x-axis. And here we are seeing a downward decreasing curve. Decreasing slope indicates that distance decreases with time, that is speed is decreasing. So if speed decreases for a non-uniform motion, you have to draw a downward curve. If speed increases for a non-uniform motion, you have to draw an upward curve. Okay, thank you.